All right, it's day 40. Day 40, gang. Let's go. Today, unfortunately, we have another bit manipulation question. But yeah, it is what it is. Let's figure out how to do that. Okay. A zero-indexed array derived with length n is derived by computing the bitwise exclusive OR of adjacent values in a binary array original of length n. Adjacent values, okay, specifically for each index I in the range of 0 to n minus 1. If I is the last index, then derived of I is equals original of I exclusive or original of 0. Otherwise, derived of I is equals original of I exclusive or original of I plus 1. Given an array derived, your task is to determine whether there exists a valid binary array original that could have been formed derived. Binary array original, okay. Return true if such an array exists or false otherwise. A binary array is an array containing only zeros and ones. Okay. A bit of a, okay, let's see. Either zeros or ones. Okay, let's see this input. So we have a derived, right? This is derived. Let's say original was something of the same length, right? It was, let's say, x, y, and z. Now x, so this one is x XOR y, right? This one is y XOR z, right? And this 0 is z XOR x. So ideally we should be able to solve this because there are 3 variables and 3 equations. Okay, if a number is if a number exclusive or itself, what is that? 0, right? Okay, we know that. Now if I do this, if I do exclusive OR of this, then we get x XOR z, which is 0. That we know. Interesting. If I do this 1 0, okay. If I do an exclusive OR of all of them, it will be 0, right? Yeah. whether there exists a valid binary array original that could have form derived. So brute force approach is to do all possible values of xyz, which is pretty long because this array is 10 to the power of 5 length, so that is impossible. Now, yeah, there is some bitwise trick here. I just need to get that right. Okay. Oh. 1 0. There is no valid original array that gives derived 1 0. Okay, why is that the case? Let's say this was A, B. A XOR B is 1, but B XOR A is 0. Okay, yeah. So yeah, if such an array is made using this exclusive OR, right, then exclusive OR of all of these values should result in 0 because every number will appear twice, right? Then that number gets exclusive ORed by itself, then it becomes 0. So the value of XOR of all of these values should be 0, right? But that if that is not true, then there's some mismatch. That can be one thing. I mean, it's just a shot in the dark, but it's worth a try. Let's try that. Let's say int res equals derived of 0 for I equals 1. Okay, this works, but why? Original is this, yeah. XOR is the necessary, and derived to have an original is XOR derived. When original and derived is binary sequence, this equals sum of derived mod 2 should be 0. What did this guy explain here? Take bitwise exclusive OR of derived array since is equals, right? Using these property to cancel out this. Yeah, why this necessary? Why this is a necessary condition? Okay, yeah, whatever. Let's do Leetcode question practice. We were on arrays and hashing. What did we do? Product of array except self. I think this is already done. I believe so. Yeah, this we did. Valid Sudoku. Valid Sudoku. Valid Sudoku. Determine if a 9 by 9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. Each row must contain the digits 1 to 9 without repetition. Each column must contain the digits 1 to 9 without repetition. Each of the 9 3 by 3 boxes of the grid should contain the digits 1 to 9 without repetition. Now rows and columns is fine, right? So we'll just write the logic for the each boxes, right? Which is also pretty easy if you ask me. I mean, yeah. So let's take this example here. Damn, bro. Now this is 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7, and 8. So rows and columns is pretty easy. Now the logic for each of the boxes is simply 0. We start from 0, 0, right? And then we do a 3 by 3 loop. Then we start from 0, 3. Then we do a 3 by 3 loop. Then we start from 0, 6. Then 3, 0, 3, 3, 3, 6. Then 6, 0, 6, 3, 6, 6. Yeah. We just add 3. That's pretty much it, right? So let's write the solution. And it is for sure 9 by 9, right? Yeah. I mean, that's what Sudoku is. Now, for int I equals 0, I is less than. I is less than 9, I plus equals 3. And for int j equals 0, j is less than 9, right? J plus equals 3, right? If invalid small square starting from I, j, and we pass in the board. Let's call it 3x3 square, then return false, otherwise return true. Boolean invalid 3x3 square. We have a board int I int j, then for I equals whatever, man. Let's call them row and column. Then for int I equals row, I is less than row plus 3, right? I plus plus for int j equals c, j is less than c plus 3, right? J plus plus. We need a boolean, right? Boolean of scene, new boolean of temp, right? initially everything is false. Now if scene board of I j, then return false, as scene of board I j equals true, and return true, right? Then for each row and column, for int r equals 0, r is less than 9, r plus plus, how do we check row? Yeah, we simply pass in that, right? Yeah. Simply this logic here, right? For int c equals 0, c is less than 9, c plus plus, if scene board rc and return false, then scene board rc equals true, right? For each row, then for each column, for int 0, c is less than 9, c plus plus, oh, character. Damn, man. Now, do I subtract 1 or 0? I think so, 0, right? Minus 0. Minus 0. And minus 0 and here also, right? Oh shit, man. At line 6, I messed it up here. Should be here, not there. And line 26, yeah, should be here. Index -2 out of bounds. What? How is it -2? Oh, we have a dot. Fuck. If board rc is equals a dot, then continue. The fuck? It is a char board, right, character? What am I missing here? Okay, it's on dot, right? But we are checking here. Board RC is equals a dot, then continue. Or a dot, right? 1 to 9 or a dot. Compared to Car's Java. Yeah, that's what I'm doing, right? Is it dot equals? Oh shit. Shit, man. I am a dumbass. This might work. No, it doesn't. False. Why is it false? Five, 3, 7. 5, 3, 7. For each column, C is 0 and R is going from 0 to 9, right? Okay, testing square at 0, 0. Right. For I equals 0, I is less than 0 plus 3, which is 3. I plus plus, correct. Yep. And j equals 0, j is less than 0 plus 3, which is 3, j plus plus, correct. If board of ij is a dot, then continue. If scene board ij minus 0, return 1. So it'll be 0, 1, 0, 2. Then sorry, it'll be 0, 0, 0, 1, 0, 2. 0, 0, 0, 1, 0, 2. Then 1, 0, 1, 1, 1, 2. Then 2, 0, 2, 1, 2, 2. 2 2, right? Oh shit. Why are... What? What the fuck? I equals I plus 3. Oh, no. What? What the fuck? Okay. Then why is it failing if scene is false, right? And it's not going anywhere else. Why is it false? I'm returning true at the end here. It's not even failing, right? For int I equals r, I is less than r plus 3, I plus plus, j equals c, j is less than c plus 3, j plus plus. If board ij is a dot, then continue. Then we log, then we check if it is seen, then return false, else we would have seen true. Then after that, what happens? Is this? What the fuck am I seeing here? Why is it not going? What the fuck? So there is a problem in this loop. For int I equals 0, I is less than 9. Then I increase the value of I by 3. Similarly for j, right? J equals 0, j is less than 9. J equals j plus 3. Return false. Oh. Oh my god, I am so dumb, man. I am the dumbest person I have ever met. My brain is cooked. Fucking hell. It's too late, man. It's been a long day. Fuck it. Fuck this. Alright, this was enough Leetcode for today. I'll be back next week. Make sure you subscribe. And yeah, I'll continue in the same fashion. One daily challenge and one from Leetcode list. Yes. Let's go. GG's.